Hello, class. Okay. We are, what class is this? Let's see here. This is calculus, unit 9 integrals. We skipped 9E. Why did we skip 9E? That looked like an interesting worksheet. I don't know. We're going on to 9F, the definite integral. If you're curious, the reason we skipped 9E is we're a little crunched on time this year because of some unforeseen circumstances, and 9E was interesting but not terribly relevant. So we'll go ahead and skip that one, and we'll go on to 9F, which is relevant. Okay, so the definite integral. We've been studying indefinite integrals, which you may have not been aware of. I think we just called them integrals. We didn't call them indefinite integrals because we had nothing to compare or contrast them to, like the definite integral. So let's go back and talk about integrals. So the antiderivative of 2x with respect to x. So we're finding the antiderivative of 2x. Okay. So it's written appropriately, so we can simply use the inverse power rule. So it's 2x to the first. So it's 2 over 2 x squared plus c for good measure. So my final answer is x squared plus c. All right, now we will evaluate the definite integral. So indefinite, we're not quite sure what it is. The closest we can get is x squared plus c. So x squared plus any number, if you take the derivative of x squared plus any number, you'll get 2x. Okay, but it's indefinite. We're not quite sure what the c is. It's definitely not quite something. It's indefinitely something. Okay, so this one. All right. Now, we will take the antiderivative of 2x just like we did before. Okay, so the antiderivative of 2x is 2 over 2 x squared plus c. Now, we took the antiderivative with respect to x, so we will move these numbers over here. So this is the notation to keep track of the 0 and the 4, but we took the antiderivative with respect to x, so we have to get rid of that symbol. All right, now, 2 over 2 is 1, so we have x squared plus c. Okay, now what the 4 and the 0 mean, I wrote this a little big. Okay, now we have to plug in 4, so 4 squared is 16 plus c. So now we're plugging in 4 for x. Now we plug in 0 for x. So 0 squared is 0 plus c. Okay, now 16 plus c minus 0 plus c. Distribute your negative. So it's 16 plus c minus 0 minus c. So plus c minus c cancel, and we're left with just 16. Now you might say, well, why did we plug in 4 and 0 and subtract? Because we're supposed to. That's how you evaluate a definite integral. So the answer is definitely 16. That's definitely an answer. So that's why it's called a definite integral, because you can definitely get an answer. So again, once you take the antiderivative, then you plug in 4, see what you get, then you plug in this number and see what you get, and you subtract. That is how you evaluate a definite integral. You might ask why? Because that's the definition. That's what you're supposed to do. Okay. Let's move on. Okay. Next idea. Graph the triangle enclosed by the x-axis. So this is the x-axis. So the x-axis is one of our bounds. So graph the triangle enclosed by the x-axis as the lower bound, 2x as the upper bound, 2x. So 2x, we can write that, the upper bound, as 2x plus 0. So the upper bound is y equals 2x plus 0. That's in the form mx plus b. So b is the y-intercept, and 2 is the slope. So the y-intercept is 0. So you go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So that's the upper bound. Okay. And x equals 4 is the right bound. So go over to 4. 1, 2, 3, 4. 1, 2, 3, 4. That's the right bound. So x is 4 and y could be anything. So we have an upper bound, a lower bound, and a right bound. So we have enclosed a triangle. Okay. So we have now enclosed this triangle. All right. Now what are we doing? We don't know. It says, graph the triangle enclosed by the y-axis, blah, blah, blah. We just did that. Now find the area of this triangle using the formula from geometry. Area equals 1/2 times the base times the height. Okay, the area of this triangle is 1/2 times the length of the base, which is 1, 2, 3, 4, times the height, which is, let's see. It looks like the height is what, 8? 1/2 times 4 times 8. Find the area of the triangle. So half of 4 is 2 times 8 is 16. Can you see that? Is that dark enough? So the area is 1/2 times 4 times 8, which is 16. Okay, what do you notice about the answers from 2 and 3? Problem 2, the answer was 16. And problem, holy cow, they're the same. Problem 3, the answer is 16. 3C, what do you notice about that? They're the same. Holy cow. Why is learning this calculus method useful? I don't know. Let me think about this one. Okay. Now, this gave us the area of a triangle. This top bound is straight. Everything is straight. So the calculus method wasn't needed for this problem because the bounds were all straight lines. Okay, why is this calculus method useful? It finds the area. It finds the area. Under a curve. Now, in this problem, our curve, 2x, wasn't curving. So we didn't need calculus. Geometry worked fine. But what if this top bound was curving? Then geometry wouldn't work, because geometry formulas only work when there's straight lines, like rectangles, parallelograms, triangles. So this method finds the area under a curve, and this is any curve, not just a straight line. Okay, so that's why the calculus method is useful, because it finds the area under a curve, or more specifically, between a curve and the x-axis. Okay, so let's try the next one. All right, the antiderivative of x to the third is 1 over 4 x to the fourth plus c. Now, -2 to 0, we moved it from here to here because we took the antiderivative with respect to x. So this and the dx is gone. We did that, but the -2 and the 0 are still there. Now we're going to plug in the 0. So we get 1/4 times 0 to the fourth plus c. And we plug in -2. So we get 1/4 times -2 to the fourth plus c. So 0 to the fourth is 0. 0 times 1/4 is 0. 0 plus c is c. -2 to the fourth is, let's see, a negative number to the fourth is positive, and 2 to the fourth is 2 times 2 is 4, 8, 16. 16 times 1 is 16. 16 divided by 4 is 4. So we're subtracting 4 and subtracting c. I will distribute the parentheses. So we're subtracting 4 and subtracting c. So now c minus c cancels, and we get -4. That is the area between the curve and the x-axis. Areas can't be negative, so that's very peculiar. Let's explain the solution with a sketch if we can. Okay. We will graph x to the third. All right. We will graph x to the third. 0 to the third is 0. 1 to the third is 1. 2 to the third is 8. 5, 6, 7, 8. 2 to the third is 8. -1 to the third is -1. And -2 to the third is -8. -5, 6, 7, -8. So that's here. Okay, now, -2 and 0 are my left and right bound. I think I forgot to explain that clearly here. 0 and 4, 0 is my left bound, 4 is my right bound. So you put the left bound on top. The left bound goes on top. And the right bound goes on the bottom. What did I say? The left bound from 0 to 4. What was I saying? The left bound goes on the bottom from smaller, from 0. The right bound goes on the top. So from 0 to 4. All right. So smaller to larger, smaller to larger. Okay. Now, my bounds are from -2 to 0. -2 is smaller, 0 is larger. So from -2, that's smaller, that's here. So that's -2 to 0. So the area between the curve and the x-axis. So that is here. From -2, smaller, to 0, larger. So -4 is this area. Well, not quite. So 4 is the area. The 0 means it's located below the x-axis. So think of the 4 as the area and the negative as the location. It's located, the area is located below the x-axis. Like if your velocity is -20, your speed is 20, the negative is like the location or the direction. So if your velocity is -20, that doesn't mean you're going -20 miles an hour. It means you're going 20 miles an hour, but in the negative direction. The same idea is here. Okay. Set up a definite integral that yields the area of the given region. So the region is here, between the curve and the x-axis. And then we'll evaluate it with calculus. Okay, let's give it a try. So the region goes from -2 to 2, from -2 to 2. And we have 4 minus x squared dx. Okay, so we're trying to find this area. So we take the antiderivative of 4 minus x squared. The antiderivative of 4 is 4x. The antiderivative of x squared is 1 over 3 x to the third plus c. Okay, now, hopefully we did that right. I think I did. Now we're going to plug in 2 and -2 and subtract. So if we plug in 2, we get 4 times 2 is 8 minus 2 cubed is 8 times 1/3 is 8/3 plus c minus -2 times 4 is -8 minus 1/3 times -2 to the third. -2 to the third is -8 plus c. Did you notice something? C minus c pops up in every problem. They always cancel. So if you look up this method on a YouTube video or Khan Academy textbooks, they often don't write the c's in the first place. So they wouldn't even take the time to write them down and cancel them because they know they're going to cancel. So we can just forget about the c's. They always cancel. Okay, so now we have 8 minus 8/3. Now be careful of your negatives. You have minus a -8, that's plus 8. And then you have -8 times -1/3. That would be positive 8/3, but then you'd be subtracting that, so it'd be -8/3. Oofed up. These negatives are a nightmare. So now I think I've distributed correctly. Minus a negative is positive, minus a negative is positive, but times this negative is negative. So I think I'm okay. 8 plus 8 is 16. And -8/3 minus 8/3 is -16/3. So 16 minus 16/3 is, I don't know. We'll multiply the top and bottom by 3. So we get 16 times 3 is 48/3 minus 16/3. 48 minus 16 is what? 32/3? Which is 10 and 2/3. So you're telling me the area of this region is 10 and 2/3 units? Like if this is 1 inch, this would be 10 and 2/3 square inches. So from here to here is 1 inch. This would be 10 2/3 square inches. And it's positive because it's above the x-axis? Interesting. All right, class. I think you're ready to try a few problems, try a few sketches, see if this makes sense, and let me know if you have any questions. Good luck.